Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of domain and range of exponential functions. This is standard A.9A in the great state of Texas, and we are using item number 18 of the 2023 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So it seems like a pretty simple equation here. P of x equals -7 times 4 to the x power. So it doesn't say anything about exponential functions there. Let me tell you why I called that out in the intro here. Because if we're looking at these standard forms, right, you're not really going to see anything that looks like that. There we go. Let's get that over here so we can see what that looks like. Right, our standard form of our linear equation, right, is going to be that ax plus by equals c. Slope-intercept, we're used to that y equals mx plus b. The standard form for quadratic is the ax squared plus bx plus c, but our x is in that exponent location, right? So we're not seeing anything in what we would consider our quadratics, our linear, or anything in here. Quite honestly, we don't have anything to help us, which means we need to come into the STAAR test with this kind of already in the back of our mind. A lot of our work in Algebra 1 is with linear equations, with quadratics, but we also have exponentials, right? So our exponential, right, if we want to kind of think of it like this, y equals a times b to the x. And so in this case, our y is replaced by that p of x. But what do we have here? Okay, so this a is going to be our initial amount. So if we are talking about investing money, right, that's going to be our principal. It's going to be the amount of money we're investing. Sometimes we use it with population growth, and it's going to be the starting population. This b, right, is going to be our rate of change. So it could literally be like an interest rate. It could just be a percent change, right? And a lot of times we have to watch out for that. It needs to be greater than 1 if we're dealing with a percent change, so like a 7% change. We'd actually need to change that to 1.07, right? That 0.07 grabs that 7%, but then the 1 means it's going to be an increase because it's going to be greater than 1. And then here is our multiplication, right? This is our time unit. All right, typically it might be years, might be weeks if we're talking about those real world situations, right? So what is it multiplying by? In this case, we don't have any context, but we are looking for the domain, we are looking for the range, but we need to have this in the back of our mind. That's just the standard form for an exponential function, right? The domain, well, that's the same thing we've been dealing with in regards to domain and range of linear functions, domain and range of quadratic functions, okay? So the domain is going to be the set of all independent variable values. Independent is going to be, let's see if I can spell that correctly and talk at the same time. Independent variable values are mainly your x values, right? Unless you get a real world situation and they call it an r or a t or something like that. So your range is going to be mainly your dependent variable values. And so that could be y values. Typically, in this case, right, it's going to be our p of x. So that's going to be our dependent variable values. And so we're trying to describe the x and the y with the domain and range. We don't know what this looks like, but we've got several options here. Let's open up a graphing calculator. In this one, let's just go ahead and do our Desmos. We could do the other one as well if we need to. But let's go ahead and just do that, and let's just type this in here, right? So we can go ahead and type in our p of x, right? And for this case, let's just call it y equals, and then we'll call this our -7, x, or -7, and then we'll need this times 4, and then we need to go and get that up to the x power, right? And there we go. If we look at that, we see that that domain, right, is going to be infinite because it goes from left to right, but the range is going to be all real numbers less than 0 because it asymptotes right there at 0. So we can say that our range is going to be all real numbers less than 0, b.